welcome to our webinar. We're very excited to be here today to talk to you about how to troubleshoot your pcap files using Visual BACnet. As per usual, this is being recorded, so if you want to share it, look at it later, you're more than welcome to. We also have done this webinar twice before, and those clips are all on our YouTube channel, so feel free to check them out. And of course, feel free to ask any questions in the question box throughout this webinar, and we will get back to them as best we can. So without further ado, I'd like to introduce you to, so I'm Monica McMahon. I also have Daniel Tan with me, one of our BACnet experts, and Ryan Houston is on the call as well.
Good morning.
I don't have a title for you, Ryan. It's Visual BACnet expert, our field expert. All right, so I'm going to share my screen. We have had 4 files shared with us. If other people have some that they want us to take a look at, we will if we have time, but I know we have a bit to cover here. So we have a university medical center here, which I want to start with. So I'm just going to see if we can unmute if the person who entered it is on the call. All right, so I'm not sure if they are. We'll just sort that out. But this is something that we see a lot. So typically, if you have a network health score of 100%, there's a very good chance that it's not perfect. I'm sorry. But we actually have not the right data. So in this case, we're seeing 3 devices. In our 15 minutes, we had about 1,600 BACnet packets. Total packets. Yeah, good catch. So 250 BACnet packets, which is not very many. So likely what happened here is that we're capturing the wrong place. So Gerhard, I believe Gerhard is online, and this is his capture. So maybe if we can unmute Gerhard, we will ask a few questions. Oh. Hi, Gerhard.
Hello. Can you hear me?
Can you tell us where you captured this file from?
Off the server.
Okay. So you captured it at the server.
Correct. Yeah, we ran a Wireshark capture, and it's loaded on the file, and I just grabbed the file out from there.
Sure. So capture connected to the server using Wireshark.
Do you usually expect the traffic to be high, or is this normal for you?
We have a lot of traffic, correct.
Sorry, can you say that again?
We do have a lot of traffic on our network.
We have a lot of traffic.
So you would expect 3 devices, correct?
Pardon me?
You would expect more than 3 devices?
Oh, yes, definitely. Yeah, we have maybe about 120 different devices out there.
Okay. And do you have a base under your server?
No, we do not. This is a Siemens network.
Okay. Is it possible that there's another NIC that you could have captured on?
Possibly, right. I have to go back now, do a Wireshark capture again to see where I get more, obviously a lot more than 3 devices on there.
Yeah.
How about the BACnet port? Are you using the standard BACnet port?
Yes, right.
Okay. So for those of you listening, I'll just give you a little background of the questions we asked. If you have a base sitting under your main server, often all of the traffic will go through that base, and then the base will send proprietary messages to the main server. And so if you capture on the server with the JSON or snippet, you might not be able to get any data. You probably need a capture tool in a different location to do that. Or if there's a different NIC, so when you are capturing in WireShark or in Visual BACnet, you need to choose which NIC you capture on. If you capture on the wrong one, you might not get any data. And Visual BACnet automatically looks at all of the BACnet ports, the standard BACnet ports, so 47808 to 47823. If you are using non-standard BACnet ports, you can add that to Visual BACnet before you upload the file, and it will analyze it using those ports.
I would say for the next capture, if you're gonna do it, filter out the non-BACnet traffic and maybe get a longer capture, and you'll see what we get. Because from the look of this, it doesn't seem like it's talking much, aside from that spike in the start of the capture.
Yeah, so it looks like all of the data was at some spike at the beginning, and then there was no more talking. So potentially capturing somewhere else on a different NIC or just for more time.
We can find a pattern.
Yeah, another. Go ahead, Monica, please.
No, you're up.
I was just going to say another thing that you have to be wary of is if you run WireShark on your local PC and you're capturing off of a switch, odds are you won't see the data going by because the data is being routed to the specific destination and not necessarily back to the PC where you're capturing. So in that particular case, you would need to use a hub if you could find one, or create a mirror port on a managed switch to be able to get that data. Unless, of course, your core application is on that PC, and then it works that way as well.
Right, right. Okay, so there's not a lot more we can do with this one, but we would recommend going back and trying to capture it for a longer amount of time and checking those NICs, and also the PC you're capturing on. So we're going to move on to our next file. If people have questions, feel free to put them in the chat. We'll go on to this other one, BACnet Capture 3. And just checking to see if our person's online. All right, so Greg is online. We'll unmute Greg and get a little bit of background on this file.
Can you hear me?
Hi, Greg. So this one has much more BACnet data, 35%. So that is
all of them.
Everything. Oh yeah, all BACnet and BACnet broadcast. 28 minutes, so a little bit longer. That's good. We typically recommend an hour, but this will definitely give us something. Interestingly, here we have a massive spike, and then a lot of data for 20 minutes, about? No, 10 minutes?
Yeah.
10 minutes? And then nothing, almost nothing. So
when this happened, I'm curious, like, what's the traffic at this spike, and what's the traffic that's going on for the 10 minutes before it drops silent? So what we usually do is I go into BACnet Browser, and the BACnet Browser kind of it categorizes the different sources, destinations, service choices based on time. So here I would usually go into service choice and see what's actually going on at that time. So a lot of read properties.
And it looks like here the who is, that little blue box, the amount of who is stayed consistent, as did the IMs, but the read property is the thing that really changed also. Let's look at all of those read properties. So now we're looking at the source of all of those read properties, what device was sending them. And there's a lot of them. So this turquoise, this turquoise one here looks like it stayed pretty consistent,
right?
But this green one dropped a lot, as did all of these other ones. Mm-hmm. Or should I say green? Maybe blue. Yeah.
So what I'm suspecting here is it might be, doesn't look like a usual periodic polling. Could be, Orion, do you have any insight on that?
Yeah, it could be something that was taking a look, such as maybe your front-end application took a look for a bunch of controllers, or potentially there could be analytics in here. Greg, do you have any insight on that? If you could type it in the chat.
Well, we'll find out. He'll probably type back to us.
The other, sorry, one more thing, Monica. The other thing it could be is if you're running your front-end application, you could be asking for data, such as loading up a graphic or refreshing some trend log data. Trend log is probably more accurate in this case, being all read properties. Mm-hmm. And once you get the data, it's not updating any further until you ask for it once again.
Right.
Yeah, so it might be nice to have a like a 1 hour file to see if it's updating it every half hour. Let's see if we have, no, okay. But I'll take a look at this 10.00.247 that I think is sending, it dropped by a lot. Oh, I did a fun thing with my pointer and it. Okay. Right. So now we're looking at for all the read properties sent from that source, 10.0.0.47, who is it sending it to? Now that 5503.
It's probably the turquoise one.
Yeah, so it stayed consistent, although it did. Oh yeah, it stayed consistent. Okay, so if you're worried about the pure amount of traffic on your system, that would be one to look at. If your system's getting clogged, you would want to look at that. In this case, we're more concerned about the mass drop-off.
Right.
So that's the one we're the least concerned about.
So the first there would be the read property request to this, or request or response to this, because we have not filtered by the request or response, but if we want to know, we would see CPU type request. So most of all of them, yeah, are actually read property requests to all these destinations.
Yeah. So if we want to, we can click into one of them, and then we can just go into the actual frame, and you can see what it's requesting. Yeah. So in this choice case, it's looking for the vendor identifier. You can see that here. The next one, vendor identifier. So it's looking for a lot of vendor identifiers, which is not,
yeah,
for the same device.
It might not be, the traffic might not be crucial information to be polling every 10 seconds almost.
Mm-hmm. So it may be that it got a response and received the vendor identifier and then stopped sending anything. So we can look at the traffic from the destination back to the source. So 10.0.8.27 as a source. 10.0.8.27. Going to here. It sent a read property and acknowledgement. And we can look at what they are.
Probably the vendor.
And it's the vendor identifier.
Vendor 7.
Human. See? So it responded, I can't remember what it was, 224 times. So that's not ideal. question is the packet just sending the vendor identifier. So the previous one we were looking for, it was asking the source, which was 10.0.0.247, was sending a read property to 10.0.8.27. I'm guessing this 00247 is the main server, and this is a device out there. And so it was saying who is the vendor for device 120, and then now we're looking at the reverse of the response to that.
For device 80027.
Oh, sorry, for device 80027, looking for the vendor identifier, which is.
But the 120 is the integer that represents vendor identifier.
Yeah, so it's the vendor identifier code.
Yes. And then 7 is actually the vendor.
So this is the response saying it's number 7. So every vendor, every single vendor out there has a number associated. When you scroll over something in Visual BACnet, you'll see, no, not here. You'll see it pop up and it will say Siemens or Logic, whoever it is. We've just cross-referenced and said, okay, we know 7 is Siemens, therefore we'll put the information in. But the 7 represents that information. Okay, so the fact that it responded a lot of times and was still requesting it is a bit problematic.
Can be improved, but yeah.
Yeah. Is there anything else in this file that we wanted to look at?
To check, we have.
So all of the critical text tasks are flat.
So slightly high broadcast traffic, but still okay.
You're okay for now. There's a slightly high longest response time.
Yeah.
Yes, 2.7 seconds.
The one thing I will mention about the broadcast traffic that is slightly high, it averages over the whole file. So likely it was super high here and then really low here. And that's why it looks okay. So
Brian was going to do longer.
Oh, you want to look at the wrong, sorry. 2.7 seconds longest response time. And first thing I noticed is that all of the requesting devices are the same device. Makes sense. That's pretty common. It's the server.
Yeah.
I'm guessing. So we've got a Schneider device. So this is where you can see the black pop-up with the name that we pulled from that vendor ID. And so a bunch of different devices, all 10.0.3s and 10.0.8. So those may be 2 different buildings or 2 different areas. These ones aren't too bad. Mostly just this, maybe the first two that are over a second are concerning. So we'll look at this one from your standard device to your Delta device. So here you can see the request and the acknowledgement that took so long. So
it could be that if this happens in the first few minutes, might be because there's too much traffic on the network and this just takes a bit longer to respond.
Yeah. So this isn't a crazy long response time, but you may often, one of the challenges with response times is that the actual devices sending and receiving are not always the problem. Often it's the ones in between that are the problem. So it's going through a path that is really congested. So if you happen to know what router it's going through, you can go into the BACnet browser and see if that router is the destination for a lot of information.
So basically what we're seeing here, Monica, is we're seeing a lot of vendor ID requests from both sides. The source is requesting the information and the destinations are receiving it back from the source.
Okay. Sorry, just a side note, we're getting some feedback that our audio is bad. If people can just confirm that it is that, and we can switch to a different audio method. Just let us know. Thank you. Yeah, sorry, Ryan.
Oh, no worries. You got all that?
I think so. So we're going to move on because I think we'll get into a lot more of this stuff on another file. So we're going to look at this university pcap. I don't think Chris is online, but we will go for it anyways because there's a lot of interesting stuff in it. So, oh, Chris is online now. So we'll try unmuting him and see how it goes.
Hello, can you hear me?
Yes, sir.
How are you doing, guys?
What can you tell us about this file or about your network?
Just say that again, Monica. You're quite quiet then.
Sorry. What can you tell us about this file and this network?
So yeah, that file is captured from one building using one of your Optigo capture devices, and it's just solely looking at one building on the system.
Okay. Perfect. So we will let you know if we have more questions.
Okay.
So actually that feeds quite well into a question we just got in. Someone asked if there's a way to use Visual BACnet Live. So we actually took this, the way that Chris is using it is it's capturing constantly and uploading the data on an hourly basis and analyzing it and giving alerts and things. So there absolutely is. We have taken one of those captures and we're looking at it from a troubleshooting perspective. But yeah, there's definitely a way to do that. Okay, so circular network. So we always, with our diagnostic tech, start at the top and work your way down. We got a lot of circular networks here, and this is a diagnostic tech that can be a bit challenging, and you will always know, you will almost always, if you have a circular network, it's pretty obvious because things just are not working on your network.
Yeah, and one thing about this tech is it tries its best to flag potential circular networks and sometimes it will flag false positives. Like in this case, it is not actually a circular network. The way you can confirm this is clicking the check, click onto one of the source and destination pair, and you'll see a list of packets in the bottom left table. If it is indeed a circular network, the hop count that which we will see here will be in a decreasing manner.
So I'm actually going to just show you what that looks like. So this is
Give it a while.
Okay.
Yeah.
It will solve itself in a moment.
And the reason we picked it up is because the hop count is really low, and that's usually indicated of a packet going through a router after multiple hops, and that's why the hop count is really low. But in this case, it's probably a misconfiguration on the initial hop count value.
So the BACnet standard says that every packet that's sent should start with the hop count value of 255, and every time it goes through a router or a device, it should be decremented by 1. So if you have a hop count of 5, according to the standard, it should have gone through 250 different devices. That's a lot of devices. What happens sometimes is the standard is not always followed, and a device will send a packet with a hop count that is not 255. Typically, the most common one we see is 15, which is 4 bits instead of 8 bits. This one looks like it's starting at 5, so I don't have an explanation for why.
Or it might have gone to 10 hops before it reaches the capture point, but we cannot say for certain.
So let me skip that.
This would be a case where you go back to your manufacturer and ask the question.
Yeah, and the challenge with this one is that often it is a manufacturer thing. Typically, you can't set the hop count, or at least I haven't come across devices where you can set the hop count. So there's not a lot you can do. So this is an example of a through circular network. And once it loads, we do have a whole 10-minute webinar on circular network, so feel free to check it out on our YouTube channel. So here you will see the hops are going 9, 7, 5, 3. So it's going back and forth between two devices, and we're seeing every second packet, and it's decrementing.
And then let's try.
8, 6, 4, 2, 9, 7.
So that's a pattern you'll see if that's actually a circular network on your system.
Whereas we are not seeing that here. And just so you know, if you ever want to know how we do our diagnostics, and you can figure out information like this, we do have all of this information up here that tells you how we flag them, and that can help you work through some of this stuff on your own. Okay, so what we're seeing here is you have some low hop count issues, but as long as I'm not going through any 5 more, so once you hit a hop count of 0, the packet will just be dropped. So if it's starting at 5 and going through 6 devices, all of your packets will start being dropped. So something to be aware of, but likely not a big issue.
What is slightly odd to me on this capture, if you can still hear me, the router addresses there, they're different buildings, so I'd expect everything to be within the same building, so everything should be within the 106478 range. So to see addresses from 10684, there are the buildings on the campus. Any ideas why they're sort of getting involved?
Oh.
Could be through your BBMD. You're all everything's connected through BBMD, correct?
Correct, yep.
So these 168 devices are from a different building than these 64.78.
Correct.
And okay, and they should not be seen in this building.
No.
What's the data?
Let's browse and see what they are.
Okay. So we're going to go into the BACnet browser, and we'll start with all of the sources that are talking, and we'll just see who's talking. Okay, so the 10.64, the 10.65 are the building that you captured on. So those are okay. Correct?
Yeah, I think it's 106478, which is at the bottom.
For the top.
And this one.
And yeah, and the top, yeah.
This 192 is a different building.
That's a different area as well.
Okay, so let's see what it's sending. Who has? Daniel, what's the who has packet?
Who has is it's usually finding for the device that has an object. So in this case, it might want to find who has object, who has a certain object name, and then it will be broadcasted, and whichever device that has that object name would respond with an I have. So in this case, most of the request that it's doing is finding out who has a certain object and nothing more. But the weird thing here is it's been sending out a lot of who has requests, which might be, yeah, that is weird.
Yeah, so I have never seen a file with this many who has. So
this becomes interesting when you have a who has. It goes from I have an established data link, source and destination, and I'm always getting the data. Now the data link or the route to that network has disappeared or changed. Now you're asking for, hey, where did it go? Who has this? I lost the information and it's no longer there. This can happen in a few different ways. It can happen whether you're doing moving stuff around, if the site is being constructed, not fully done yet, if network changes have been done. but the controllers haven't been updated. Has any of that happened on your site, Chris? Has anything changed or moved?
I don't think anything network has changed. Some of the structure and how we've programmed the software behind it and the naming conventions has changed, but no additional hardware or networks have been altered.
The naming convention shouldn't make a difference.
No, but it is interesting to note that it's in this hour capture, there were 347,000 who has and only 1,100 I have. Oh,
So
or 11,000.
That's most of your data.
Mm.
If you go to the summary screen.
It's very likely that either the I have is not being registered and the requesting device is just kept requesting for who has, or it's just finding for objects that are no longer exist.
Yeah. So someone just asked if this can be fixed by the COV subscription. No, the COV subscription would it would show up with a diagnostic check that shows the COV traffic, and that once it knows who has the object, it will, and it's subscribed to the change of value notifications, it will send that. But right now it's looking for who actually has that object. Good question.
Well, we don't have a who has a check here. No. So it's to figure out the object itself is not that straightforward. You have to go into the BACnet browser and slowly look into the frames and look into what object it's requesting for.
Yeah, so we could do that through the BACnet browser. We could look at all of the who has. We got sidetracked from our original goal of seeing why that device was talking.
So if there's that many who has, Chris, there's probably a lot of devices that aren't being updated on the information. So something's not working correctly, or nothing's under actual control, and so your site's not being directly affected.
Okay.
So in this case, I would say scenarios like this can be a little bit overwhelming of like, what do I do to get rid of all of these? I would say once it loads here, maybe choose one device that's sending who has and look and see if you can figure out what it's asking for. So we can just go into the packets, figure out what object it's trying to find, and then you can go and try and identify that object, make sure that it isn't an object you could be looking for, and fix that one. And then if you can do that, then you can replicate it across all of them. But just to make it a little more bite-sized, I'd focus on one.
Yeah, okay, cool.
Trying to do too much on my computer right now. Okay. So we will start by looking at the service choice and looking at all of the who has. Yeah, you can look at. So service choice, all the who has, and then we should look at the who has request. They probably are all requests. Yeah, okay, so they're all requests. Let's look at that top one, because that is one that we know should be in the building. It makes sense that we're seeing it, but we're not sure why there's who has.
This one is broadcasted.
Okay, so .255 is broadcast. Most of you probably know that. Okay, so let's look at the non-broadcast ones, because they're super replicable. You can fix one, you can fix 16 of them. 1,700 frames to look through now.
But if it happens one thing, it's probably the same.
Hopefully. Kind of hopefully.
One is the APU object name.
All right. So it looks like the third floor female washroom. So age until first floor 3027, 303.
Requesting for which device is this range that has this object?
That's it. Yeah. It's a different one. So it's different as 03. Yeah, and this one's 05 at the end. See right here, it's 05.
It looks like it's looking for a bunch of set points and that sort of statuses from a bunch of different controllers in rooms of that building.
Could they be trend logs?
Is that what your TLU stands for?
Possibly. I know we've got a lot of trend logs for the toilets for water, safe water, etc.
Yeah, probably, but before it even got to requesting for the trend log, it's trying to figure out which device has this object.
So it could be your trend logs know that they should be requesting that, but they can't figure out which device to send the request to. So they're saying who has that object.
Right.
And this might be
Oh yeah, so here you can see all of these first few were at 22 seconds, and then a bunch at one lone range. Okay, so this one I bet will match is 27. Well, we can look. 06 CFS. That's not the right one. 06 CFS. Yeah, so you can, I mean, you could go through a couple more to check, but it's sort of sending a set of them and then a set of them every 2 seconds.
It's probably just about 10 or 15 different objects that should probably it.
So you could go back to this source and say, okay, it's programmed to find that, to ask for that object, but it can't find the device. So is there a way that you can fix that?
So it's very possible in this scenario that if you're looking for an object name and the object name is not exactly, if this object name that it's looking for and the object name that you have are off by even one character, it may not find it. As opposed to looking for directly a device instance. And this is almost a fault in tagging. Like if you're looking for the wrong tag that doesn't exist, then you wouldn't be able to find it. So I would double check what it's looking for to what you actually have on your BMS system to see if it correlates. If it doesn't, then you're going to have to change what that reference is so that you can find it easily.
Okay, I'm going to answer a couple questions here. Someone said they're not showing a show frames, not seeing a show frames button. It may show up in a different location. So it might be by different location. I mean, it might be here on the end, depending on the size of your browser. But you should have it. Everyone should have it. There's no difference like or anything.
What device are they using? Are they using a standard laptop or PC?
I don't know, but Robert, you could let us know. And if you're still not seeing it, we'll get in touch with you afterwards and we can troubleshoot it. And then someone else wanted to know what defines our diagnostics red, green, yellow. So I think we'll go back to the summer screen anyways, see if we can look at a couple other things that in Chris's file. But there's a few places we have those thresholds. So one is the overall network health score. If you click on it, you will see a total breakdown of the score here. So these top ones are critical checks. They decrement 10, 20, or 40% right off the top. And these bottom ones are scored checks. So they average to make the base of your score. So we give it all that information there. And then if you want to know what the threshold for each individual diagnostic is, we can see that in this little wrench. You can't change it but you can see what it is. And in monitoring, you can see that in a different location. All right, just a couple questions answered there for you. Okay, so did we want to look at, what else do we want to look at in here? The unresponsive router. So next in line. All right, so unresponsive router means that some device has sent a who is router to network 7 or whatever the number is, in this case 2, and it has not received a response. Interesting to note that, so we said in the previous screen that there was 1, but you see 8 in the list here. It's because the other 7 are not 100% unresponsive. So they sent it, like for example, who is router to network 1 was sent twice and got an answer 1 time. So it's not entirely unresponsive, but we do put it here for you to know that it's not as happy as it could be. So this one though, network 2 is completely unresponsive. So one of two things in this scenario: either that device is not responding, it's offline, someone pulled power cord, it's imploded, who knows? Hopefully neither of those things. Or all of these devices, so these querying devices down here, are looking for it and they shouldn't be. So not uncommon to have a device that used to be online, you take it off, missing everything that was talking to it, but forget 1 or 2 of those devices. So they could still be looking for a device that no longer exists, or or they could be in factory still in factory reset or something.
So if network 2 shouldn't be there, we're putting the effort to look at this 5 devices.
So Chris, should network 2 exist in this building?
I'm not looking at those IP addresses. No, they shouldn't be there.
Okay. So then likely you'd want to go look at all 5 of these and say, why are they looking for network 2? We'll look at this one that sent 6 packets. I mean, 6 packets in an hour is not, compared to the who has, this is, I would say, a secondary issue. But so they're all being forwarded by CVNC. So it's likely coming from a different subnet. Oh yeah, so it's coming from that source. Okay. So you could go there and see why it's asking for network 2. Yeah.
Yeah.
Unresponsive devices, really the same process of, is it unresponsive or should it not be looked for? Oftentimes you can, as soon as we open up unresponsive devices, you can go, wait a minute, 12 seems weird in this list. So that may be one that shouldn't be talked to, whereas some of these other ones might be unresponsive. Yeah, that's a lot. 38,000 packets being sent to that one. They're probably all who has.
So if this device happens to have the object that it was going for earlier, that might be the reason why it's going for it. Yeah.
And we see. Right. Let me see what these packets are. So, oh, it's who is. Right. Yeah, so it's saying who is and not getting a response. And that is a challenge that we often don't have a lot of information about these devices because they may or may not exist and they're not talking.
Like 255, 12, 89 might not be an actual device that should be on the system.
Right. Especially 255, which is often not used because of the sub-broadcast number. Okay, so we won't spend too much more time on those. Just looking. Okay, so someone, if a device ID comes up but it's not installed in the field, what's the issue? It's likely because a device is looking for that device ID. So it's saying who is device 2475128. And you need to go to the source or the querying device that's sending that packet to say, why are you sending that packet? Why are you looking for that device? And it might be factory reset or
sometimes it's about the legacy stuff in the programming that you're looking for.
Could be a graphic, right? Very possible a bad graphic link that's missing, or it's a problem of decommissioning something and just forgot to take out some links. Pretty common problem out there, but the more that you leave out there, the more it clogs up your system.
Yeah. And so that's a great use of Visual BACnet. If you are making a bunch of changes, you can make sure that everything that you can go, okay, what are all the devices? You could use the BACnet browser to say, what are all the devices that are talking to this one device that we are going to be decommissioning, and make sure you update all of them, and then keep an eye on it after you take note and say, okay, are there still devices that are looking for this device ID that no longer exists? All right. So missing acknowledgement?
Not too many.
Not too many. Oh, interesting. A lot. I'd say it's not super normal to have this many that are only one in an hour. So there's some read property multiples. So missing acknowledgement means it sent a packet, in this case, a read property multiple, and didn't get any kind of acknowledgement. And a read property multiple, the acknowledgement would include the data.
So my suspicion would be, since the network is filled with mostly who has requests, it might have been congested for the response to come back, or even the request to reach.
Right.
Yeah. That's my initial guess. But I don't think this is the huge issue that you should look at first.
Yeah, I wouldn't focus on that. I'd focus on who has.
Odds are they will disappear.
Exactly. And same with the broadcast traffic. I mean, 50 packets per second of broadcast traffic is a lot. But it's a symptom of your who has situation right now. So again, if you focus on those who has, we'll be fine. Global who is router. So who is router to network, and then no network specified, so all networks. 34 times. And the immediate thing that jumps out to me here is that the time on each packet is the same. So it sent it in the same second.
And then this source is up 10 of 34 within a second.
Yeah.
Yeah. Good.
Oh, no.
Oh, half an hour.
Yeah, half an hour apart. 1724 and then 1754. So likely it's sending out 17 packets every half hour, but all at the same time.
And it looks like it's going through probably different BBMD.
You can see the forwarded MTBU.
Yeah. And then there's the ITK, which is the source that sends out the global browser. And on the IT side, the source, that should be the BBMD. And it looks like from the same BBMD, but going to different destinations. So it might be a foreign device on that system. Or
the original one's broadcast, and the other ones are going to BBMD.
So that's why
we're getting so many. Okay. So interesting. Still focus on who has. Okay. So I think we have a couple more minutes. We have one more file we wanted to look at. I'm just looking at these questions here. So one person wanted to know about the The vendor, I'm not sure if we already clarified this, but the vendor, so most packets, not all, but most packets that are sent from one device to another have the vendor identified. There's a field in the packet for that. And so
it's usually in IM packet.
Okay,
That
so
you will see the vendor identifier.
yeah, you'll say I am this device, my vendor is 7, and so then in Visual BACnet we just decode the 7 to be Siemens or whatever it is. So the data is in the packet, and I think that's it for questions. If there's more questions, we will get those in a minute. All right, we have an MSTP file here, and let's see if we can get, I'm not sure if Chuck or someone is online for this one. So again, there's not a, oh man. Okay, so 90%, not super normal to have that. 50,000 packets, most of them are MSTP packets. That's pretty normal for an MSTP network. And the only check that flagged is your unresponsive device. We have 5 devices that are not responding. So probably the first thing that we always do when we open an MSTP file is what Daniel just did. Open the average token round trip time or the token standard deviation time. We have 3 checks that are specific to MSTP files, and they look at the tokens. And do you want to go back to that for a second? Okay.
So,
Token disruption, so if the token isn't being passed, it'll show up there. There are none, so that's not very useful. Standard deviation and average. This one is really nice because you can see the token passing. So in this case, just 0 to 1 and 1 to 0. On a bigger MSTP chain, you could say 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 4 to 6, 4 to 7, 4 to 8, and then you're like, oh, that's where the problem is in this 4 to everything area. So in this case, we've got 0 to 1 and 1 to 0.
And 2 devices, 3. Yeah.
Yeah, not super messy. Yeah. However, there are 5 unresponsive devices. Whoa.
Okay. Yeah.
All right.
Yeah, should the devices be there, or are they just, if they should be there, then check the devices, make sure that they are online, make sure that they're responsive, make sure they can reach the MSTP network.
If this is an actual MSTP device that should be talking, check your Mac master. Yeah. Otherwise, why is device 0 looking for them? And Daniel just said the usual questions. So these are a few. We do have this why it failed and how to fix it. Some sort of generic suggestions for these problems. So feel free to use those. Okay, I'm just trying to see if we have any more comments from. Yeah, maybe we'll unmute Brian. Brian, can you hear us?
Yep, I can hear you.
Hey, Brian. Do you have any comments or anything to say about this capture?
Well, obviously it was captured on the MSTP network. Those offline devices, I'm not sure. One of them we probably could account for. The other 4, we're not even sure what they are or where they might be out on the network. But the big concern we had looking at this in Wireshark was when we just sort through the BACnet portion of the capture, then like 2/3 of it is unconfirmed COVs from like one device, or it's actually 3 different devices, but one device on that network, which is like, I think there was like 1,600 packets out of the 50,000 were BACnet traffic, And then of those 1,600, 1,100 of them were these unconfirmed COVs. So how it doesn't show up here really as being an issue, but how big of an issue is that to our network?
Yeah. It could be. I mean, this is a pretty small network, so we may not have flagged it as a big issue, but for a network of this size, it is a lot of COVs. Have you checked what the change of value set notification setting
Well,
is at?
it's on a third-party device that's that we just integrate to in the system, and it's on a Corel controller, and we see these controllers in all sorts of equipment all over the place, and we see the same result no matter where it is or what manufacturer's equipment it is, and yeah, the COVs are set extremely low out of the box on these things, and it's seems to cause our equipment issues when it gets onto our networks.
So depending so you can see here, we pull out the present value. So on this device, I don't know what the value is for, but it's 209.208.207.65.432. So the COV seems to be set to 1.
Click on the APDU.
Pardon me?
Click on the APDU.
Yeah, it should.
Yeah, they're going up and down. Yeah.
That's.
So if you open the object identifier, that AV147, it might show you in there. I don't know if it shows you what the COV setting is in the.
Probably not, no. So
From here, it looks like at least that's minus 1.0.
yeah, and so
Probably.
this is one of the many situations where it depends on if that's it's not 207, probably isn't, but if it's a degree and you're in a critical lab and you want to make sure that the last icicle from the North Pole doesn't melt, that probably should be 1 degree. If it's, I don't know, something not that critical, it might be set way too sensitive.
Yeah, that's on a chiller, and that's probably like a suction pressure off of the chiller, if I had to guess, just by looking at the numbers. But I guess our bigger we know how to resolve the issue, or at least we need to. If this is, I guess, if you guys feel that it's an issue on the, the MSTP traffic, because it ends up locking up the device. There's only that one device that's on this MSTP wire. And it ends up locking up the device. It's done it a few times, and then the device won't communicate until you actually restart it. And again, it's a third-party device, so we're just trying to figure out how we can push back to the manufacturers and say, hey, the issue is with your equipment, not with ours, and we'd like to be able to use this as maybe some proof to that.
Yeah.
I think the easiest way to use that in the tool is trying to take 11, 12, 15 minutes in a capture of time is hard to see it, but running it for longer, I would recommend. Do you know how often it locks up on you?
It's probably been at this particular device, it's been a month. We've had other ones where they would lock up within a couple hours.
So I would try running this. You'd use a few captures, but try getting a 24-hour capture and see if the score changes and starts to degrade, and see what we can catch.
Okay.
20, you mean a 24-hour capture or 24 1-hour capture?
24 1-hour captures, but so we could, there's a very important distinguishing there. Even if our tool could give you a 24-hour capture, you wouldn't really know what spot inside of that 24 hours where the issue happened. But taking 24 1-hour captures, we would know with good granularity of where the issue happened. So maybe something starts to stack up and then chokes, and then maybe it automatically resets, or some buffer does an internal reset, but we would see a trend coming down in the score.
And what causes that to be an unconfirmed COV? Is that it's sending, like it's shooting out its information because the value changed by whatever the COV was set at, and then nothing replies back to it? Is that what's giving it the unconfirmed COV?
That's correct.
Yeah. Unconfirmed is so that no one would need to respond.
And it's not expecting a reply.
Yeah.
Right.
Okay, so it's not expecting one, so it's
fine. You can request a confirmed. You can set it up different, so it has.
all right.
You could have a confirmed COV that's not receiving a reply, and that would be a bad thing. So this is an unconfirmed, so it's saying, here's the data, don't respond. Don't confirm to me that you've received it. So if it's really, really critical and you want to make sure that the data it's actually making it through, you could set up a confirmed COV that would double your traffic. So every time that the data gets sent, it gets a response. So yeah.
If you confirm it, it comes back. In the setup of our network.
All right.
Okay. So I'm just going to touch base. We are out of time. I'm going to touch base on one or two other questions before we go. Hopefully this was useful to people. There will be a survey when you close. Please fill that out. We want to know what other webinars you want us to do, how we can help you more. And specifically, if this was useful, if so, what you learned, so that we can do more of this and help you more. I love this question from Robert. What's an average network health score? I believe we did a calculation. Now, keep in mind, we're a little bit biased because we tend to get sites with problems in them. That's why people come to us. I think it was in the 40s or 50s is fairly average. But we have a lot of zeros, so don't be embarrassed by that. And a lot of our hundreds are what we showed you this morning of capturing the wrong spot and the learning process of capturing in the right spot. About the proper way to capture. So another great way to capture is if, particularly to solve sort of what Ryan mentioned earlier, if you can get a mirror port or you can buy a switch with a built-in mirror port, and there are a few out there, that will help you capture all the data and get everything from one port. If you want to know more about that, feel free to get in contact with us. So I think we're pretty much there on questions. If people have more questions, let us know. If we didn't get back to them, we will get back to you outside of the webinar. Otherwise, we're always here to help you go through your files in Visual BACnet. So feel free to use this wonderful little chat down here. We'll get back to you as quickly as we can. Or email us, get in touch. Thanks so much, and have a great rest of your day. Thank you, Daniel and Ryan.
Thank you.